Okay, the last unit that we are going to go into is on substances and mixtures. So it's a little bit of chemistry, and it's our shortest unit. But we're going to basically be studying about mixtures, how do we separate them, what physical properties are the best to use to separate them. And if you remember in 6th grade, we had a huge chemistry unit where we talked about what matter is, elements, mixtures, and compounds, how they're different. And we had a huge topic about atoms. And now we're going to kind of build off what we learned in 6th grade in our chemistry unit and talk about how we take that matter and separate it. Okay, so our essential question for the day is, how do we know that substances are composed of different types of matter? This goes with learning target 28. I understand that matter is composed of different types with unique properties, and I can tell the difference between elements and compounds. Okay, so matter, if we remember correctly, has mass and takes up space, which is volume. Remember, energy is not matter because energy does not have mass and it doesn't take up space. But energy can cause a change in matter. We learned about that last year with physical and chemical changes. Matter is also made up of atoms, or we sometimes call those atoms particles. Now, remember from last year, a pure substance is matter that cannot be separated by physical means. So these are your elements and compounds. So if we look at our periodic table of elements, they are made up of one type of atom with unique properties. For example, hydrogen is made up of only a hydrogen atom with one proton, one electron, and 0 neutrons. So that is a hydrogen atom. Sometimes hydrogen atoms can have one neutron, and that's an isotope. Okay, so elements always have the same number of protons. So hydrogen elements always have one proton. Helium elements always have 2 protons. Lithium elements always have 3 protons. So remember, the number of protons determines the elements. And that's a unique property about an element. We can't take an element and separate it by physical means. You can't just split hydrogen, air in half, and it's still hydrogen. You haven't done anything to it. Okay, a compound is made up of more than one element with different properties from the original. So if we take water, water is liquid at room temperature, that compound. It's made up of 2 atoms of hydrogen bonded with 1 atom of oxygen. If you take hydrogen and oxygen by themselves as an element, hydrogen and oxygen elements are gases at room temperature. So that's what it means when we take elements and we chemically combine them through a chemical change. That's where we use that energy. And we make water. Water has different properties than the original. And we can't separate. We can't take water. If you pour water from one glass to the next, it's still water. We can't separate water, a compound, by physical means. And hopefully this is ringing a bell from last year. Okay, so now we're going to review the particle or kinetic theory of matter. So remember, matter is always in constant motion. Those atoms, those particles that make up elements and compounds are always moving. They always have some form of kinetic energy. Also, atoms are attracted to each other. The phase of matter, whether it's a solid, liquid, or gas, depends on the amount of kinetic energy. A solid will have the least amount of kinetic energy because they have shape and volume. The atoms in a solid will move by vibrational movement. A liquid has more kinetic energy than a solid because it can flow. It has shape, but it has no, it has no shape, but it has volume. A liquid, remember, will take the shape of a container. And then a gas has the most kinetic energy. So if we were to look at the atoms in a solid, these little circles represent an atom. In a solid, the atoms are packed tightly together so they can't move around a lot. That's why they have shape. So they just vibrate and kind of shake back and forth. Liquids can move, can flow, so they have more kinetic energy. And gases, because they have no shape or volume, can go anywhere. They have the most kinetic energy. Okay, so we're going to look at physical properties because we look at physical properties when we start separating mixtures. Physical properties are characteristics of pure substances that are unique and help classify matter. So examples of physical properties: the mass, the density, how heavy something is. Remember, water has a density of 1, so that's a physical property of water. Color, size, and I'm talking about length, width, and height. Those are physical properties. Magnetism, phases of matter. Remember last year you guys did a lab where you got different objects. You had a box of paper clips, you had marbles, you had a little tiny jack, and you guys had to look at the take the mass and find the density, and those were all physical properties. Boiling point, freezing point, and melting points are also physical properties of matter. These are really important when we start separating mixtures, especially by the process of distillation. So, if we take a look at solids, liquids, and gases. Solids, when they have enough kinetic energy, they will change from a solid to a liquid. The temperature at which they do that is called the boiling point. When a liquid changes into a gas, the temperature at which it does that, that's called I just said that wrong. Solid to a liquid, I apologize, is the melting point, that temperature. A liquid to a gas is the boiling point. And if you take a liquid, change it back to a solid, that's the boiling point. So those are physical properties of matter. And if you notice, if we're going from a solid to a liquid, liquid to a gas, energy is absorbed, so they energy is transferred in. If we go from a gas to a liquid to a solid, energy is released out. So that's where you're losing some energy, and that's going from more kinetic energy to less. Okay, so if we take a look at water, we're going to look at water right now. Let me change the size of this so you guys can see it all on one screen. Give me a second. Let me pause this now. Okay, so if we're looking at physical properties of water, we're going to take a look at this graph, which is showing time versus temperature. Oh no, that's not what I want. No, yep, that's what I want. Okay, so down here, this is our temperature scale, and this is over time. So at 0 degrees, and we are in Celsius right now, okay, at 0 degrees, if energy is going to be added to water, then it's going to stay as a solid, which will be ice. If we keep increasing kinetic energy, then that solid can change into a liquid. So once the temperature goes past 0 degrees, a solid will change into a liquid. That's called the melting point. So right here, the temperature of 0 degrees, that is called the melting point. So 0 degrees is water's melting point. Let me put that in on the graph. Okay, so at 0 degrees, we are at melting point. I'm going to make this a little smaller so it doesn't take up so much room. Okay, I forgot the T. All right, so like I said, when temperature starts to increase, or when kinetic energy starts to increase, we're going to go from a solid to a liquid. So whenever the temperature rises above 0 degrees, that's the melting point. So if you are adding kinetic energy to water, 0 degrees is the melting point. If we keep adding kinetic energy to water, at 100 degrees, water will start to change from a liquid to a gas. That is called the evaporation or boiling point. Okay, so 100 degrees is the boiling point, the temperature at which water will change from a liquid to a gas. Now remember, this is assuming that we're adding kinetic energy. So temperature, we're adding kinetic energy. If we're adding kinetic energy, then we're going to go from melting point to boiling point. Now we're going to do the opposite. Let's say now we're going to take away kinetic energy. So we're going to start out as a gas. Okay. If we take away kinetic energy from a gas, it's going to turn back into a liquid at 100 degrees. So if we take away kinetic energy at 100 degrees and temperature starts to fall, then we're going to have it's called the condensation point. So boiling point and condensation point are both at a temperature of 100 degrees Celsius. It's going to depend on whether you're adding or taking away kinetic energy, whether it's boiling or condensation point. So if you're adding kinetic energy, then that means that's our boiling point, 100 degrees. If we're taking away kinetic energy, it's the condensation point. That's where a gas is turning back into a liquid. Then if we keep taking away kinetic energy at 0 degrees, liquid water, if we keep taking away the kinetic energy, is going to start turning into a solid. That's called the freezing point. So 0 degrees Celsius is the melting and freezing point of water. It's going to depend on whether you are taking away. If we're taking away kinetic energy, then 0 degrees is the freezing point. If we're adding kinetic energy, then 0 degrees is the melting point. Okay, so hopefully this gives you an idea, and most of this should be a review about how physical properties relate to matter, and then we're going to start using these physical properties to separate mixtures.